All right, let's talk about finding the domain of an equation. Okay, so first let's talk about what the domain is. You probably know how to find the domain from a graph, right? Your domain is all of your x values. Your range is all of your y values. So if we're going to go graph this over here, absolute value of x plus 2, your absolute value of x makes the v. Okay, the plus 2 is a shift in the vertical direction, so it's shifting it up. So if you've learned your transformations, you will see that this is what the graph will look like, absolute value of x plus 2. Now the domain is all of your x values. So how far to the left does this graph go? Well, it goes to the left forever. And how far to the right does it go? Well, it also goes to the right forever. So no matter how far left and how far right you have, you're going to find a graph. Okay, so your domain for this case is all real numbers. It goes from negative infinity to infinity. Okay, you may also see it as all real numbers. Right, and it's asking you what kind of values can you plug in for x. And in this case, you can plug in any value for x and you will get back a y value. There's nothing off limits here. Now, let's look at another one. Let's look at something like this. Y equals square root of x minus 5. Okay, so I'm going to put a graph over here on the right. And now I know that I have this zinger shape. Zing. But I am transforming it vertically. I'm shifting it down 5. So the graph for this is going to look like this. Okay, so now you see that we don't have a domain that goes forever. Okay, our domain, if you start at the left, do I see any graph back here? No graph back here. None, none, none. Where do I start seeing a graph? Boom, right here at 0, when x is 0. And how far to the right does that graph go? Well, it goes to infinity. Okay, so my domain for this is from 0 to infinity. Infinity always gets a parenthesis, and 0 is included because there is a point at 0. So why isn't my domain all real numbers? Well, there's only two things you need to look for that's going to make your domain not be all real numbers. Okay, there's two restrictions on the domain. One of them is underneath a radical. Underneath a radical has to be positive. You can't have a negative under a radical and still have it be a real number. Okay, that's one of those imaginary numbers. The other thing is you cannot have a 0 in the denominator. So 5 over 0, that doesn't exist. Okay, we can't divide 5 by 0. It just doesn't exist. So if you have anything on the bottom that would make it a 0, for instance right here, let's say it's 5 over x minus 2. What would you plug in for x to get a 0 at the bottom? A 2. So x can be any number in the world, but it cannot be a 2. Right? You could plug in any number and you will get back something that is legitimate. That's a number, but you cannot plug in 2. Okay, so let's wrap it up here. Finding the domain from an equation. Now, if we don't have a graph and we're not looking at it, your domain is going to be all real numbers normally. Okay, normally your domain is all real numbers. I'll put a little numbers. Math people won't like that, but your domain is all real numbers, right? Which is negative infinity to infinity. But you have a restriction in your domain if you have an x under a radical. Okay, you can't have a negative under a radical, and you cannot have, doesn't matter what's on top, you can't have a 0 in the denominator. So if you get an equation with a radical, you have to make sure what's under the radical is positive. Okay, you'll see an example next.